Worked example 5.3 states that sodium chloride, or capital N lowercase a, capital C lowercase l, capital O subscript 3, decomposes when heated to yield sodium chloride and oxygen, a reaction used to provide oxygen for the emergency breathing masks in airliners. Write a balanced chemical equation for this reaction. Pause the video to see if you can do this. We are told that sodium chlorate decomposes. That means it breaks down and it doesn't react with any other chemical. We are also told that sodium chloride and oxygen are formed, so those are the products. When we count atoms, we see that the sodium and the chlorine atoms are balanced, one on each side of the arrow. However, oxygen is not balanced. We have 3 oxygen atoms on the reactant side and 2 oxygen atoms on the product side. Since neither number is a factor of the other, we need to find the least common multiple of 2 and 3, which is 6. I need to get 6 oxygen atoms on each side of the arrow. To do this, I place a coefficient of 3 in front of the chemical formula for oxygen. There are now 3 times 2, or 6 oxygen atoms on the product side. I place a coefficient of 2 in front of the chemical formula for sodium chlorate, and now have 2 times 3, or 6 oxygen atoms on the reactant side. However, this coefficient of 2 also changes the number of sodium and chlorine atoms on the reactant side. There are now 2 atoms of sodium and chlorine on the reactant side. I balance the sodium and chlorine by placing a coefficient of 2 in front of the chemical formula for sodium chloride. Let's double check. For sodium, 2 times 1 is equal to 2 times 1. For chlorine, 2 times 1 is equal to 2 times 1. For oxygen, 2 times 3 is equal to 3 times 2. Our equation is balanced, and the coefficients of 2, 2, and 3 have 1 as the greatest common factor, so we do not need to reduce the coefficients.